Thanks, everyone. Hi, thank you so much for joining us for this session on designing, creating, and innovating. My name is Kyle Watson. I'm an engineering advisor from UBC's Okanagan campus. The UBC Okanagan campus is situated on the unceded ancestral traditional territory of the Syilx Okanagan Nation and their peoples. And I'd like to take this opportunity to acknowledge the traditional lands and caretakers from where you are joining from today. Thanks so much, Erin, for having us out for this presentation.
Thanks, Kyle, and hi, everyone. My name is Erin. I'm the Student Recruitment Officer at the UBC Vancouver campus, and my pronouns are she, her. I'd like to also acknowledge the land that UBC has built its Vancouver campus on, which we work, learn, connect, and innovate is the unceded ancestral and traditional territory of the Musqueam peoples. Now, we have a few guests with us today, so you'll be hearing from Mahak, a current student at the UBC Okanagan campus, as well as Emma, who is a recent alumni from the Vancouver campus. And you might be joining today because you're interested in a future career where you'll get to design, create, innovate, or make an impacting change in our world. Our UBC Engineering alumni continue to influence positive change in our world through a wide variety of career paths. In today's presentation, we hope to give you a better understanding of how a degree with UBC Engineering can lead to unlimited career opportunities. UBC Engineering students start designing, innovating, and creating throughout their entire degree. This is intentional as it better prepares you for success in whatever career path that you might choose. So even if you know someone who works as an engineer, you might not know all of the possibilities available for someone who completes an engineering degree. At UBC, our engineering degree is the Bachelor of Applied Science. And in Canada, there is no standard for naming degrees in engineering. So you might find other schools that have a Bachelor of Science in Engineering or a Bachelor of Engineering or any other naming system. Now, what is important is to make sure that the program is accredited. That means that the program meets the academic requirements so that after the student graduates, they can work towards their licensure as a professional engineer in Canada. You won't have to worry about that at UBC, as all of our programs that students graduate from will be accredited. Now, UBC Engineering offers students two campuses to choose from, one in Kelowna and one in Vancouver. The main differences in campuses is the size and in the programs offered. We do hope between the two campuses that you can find what will work best for you. UBC degrees are recognized internationally. What does that mean for you? Well, if you pursue an engineering career outside of Canada, it is possible that you might need to complete certain requirements to meet the professional licensing, but you can have confidence knowing that your UBC engineering degree will be recognized wherever it takes you in the world. At the Okanagan campus, there are 5 specializations: civil, electrical, manufacturing, mechanical, and our new program, computer engineering, which will be starting this coming September. At the Okanagan campus, students are guaranteed a spot in their program of choice. And that means that if your heart is set on any of the 5 programs at the Okanagan campus, you'll be able to declare your program once you have second-year standing. At the Vancouver campus, we have 14 different programs to choose from, the same 5 programs just mentioned at the Okanagan campus, plus 9 more exciting programs. And in Vancouver, there is competitive placement for your specialization. That's what we call second-year placement, which you'll get to learn all about in your foundational first year. Now, regardless of the campus you choose, all students will go through a foundational first year that allows you to learn more about all of the programs before making your decision and starting in your specialized program in second year at your campus. We won't touch on anything else related to admissions today. We have some great presentation recordings all about our programs, admissions, how to apply, and more on our UBC Engineering YouTube channel. So you can definitely check that out.
Thanks so much, Erin. Something that's really cool about our programs at UBC Engineering is you do get to design right from the start. Erin touched on our first year foundational program. Students, regardless of which of those 14 specializations on Vancouver or 5 on the Okanagan campus, regardless of which direction you go in, you complete that same first year foundation. And the really cool part about that first year foundation, you're building your toolkits with your math, chemistry, physics, but you get to design right from the get-go. On the Vancouver campus, that includes 2 course codes, by course number APSC 100, where you get to design a cardboard chair. Might seem like a simple task, but it's a 4-week group-based project where you are innovating new ways to hold a 250-pound boulder and a person. You even get to present your ideas to your professors and friends. In the second term or second semester of your first year, you move into the course titled APSC 101. And this is where your first project will be creating an automated claw that needs to pick up a variety of objects. So there's additional projects that you get to work on throughout your first year, giving you flexibility to design, create, and innovate while learning about many of the engineering specializations that you will progress into year 2 and beyond. The Okanagan campus, very similar. We have different numbers for our courses, but we do have a term 1 or semester 1 course titled APSC 169. You get to learn more about sustainable engineering design, and students get to work on a variety of group projects, providing real world implications and solving real world problems as future engineers in your first year courses. Many teams have gone on to compete in challenges such as Engineering Day Hackathon or the Aqua Hacking Challenge, and super cool stuff. Getting to have that exposure to design, creation, and innovation right off the bat. In term 2, similar to Vancouver campus, the Okanagan campus progress into a course titled APSC 171, and this one focuses more so on drawing of CAM and CAD design projects. And it features our iconic end of term design competition. So all of the design teams taking 171 compete, and the top 30 get to present in front of a panel of judges and win the coveted 171 Design Cup. Super cool stuff. If you've ever noticed some innovation in the design of clothing donation bins across the country of Canada, that new design was created from one of our 171 courses. So really cool stuff. UBC engineers are making changes in the world, yes, after the degree, but it can begin as early as year 1. There's a lot of really cool ways to get involved on both campuses. Super popular opportunities are to gain extra design experience in hands-on engineering skill sets. We can join design teams, you can join engineering design clubs at the Vancouver campus. There's over 30 design teams open to students in all engineering programs. On the Okanagan campus, we also have engineering design teams and clubs and associations where you can get involved with like-minded engineering students and enhance your exposure to design, creation, and innovation. Some really cool ways to get involved and really find your own community in that first year. But you're not here to hear from Aaron and I as staff members. You're here to hear from current students and recent alumni. We've got 2 superstar students that are joining us for today's session, as Aaron previously mentioned. We have Mehek, a current UBC Okanagan engineering student, here to chat and share some experiences of what she's going through at the UBC Okanagan campus. Mehek, thanks so much for joining us for this presentation. Would you like to take it from here?
Yes, for sure. Thank you so much for the warm introduction. My name is Mehek, and I'm a first-year engineering student here at UBC Okanagan. And I wanted to share a little bit about my student experience to give you all some insight on what your first year at UBC could look like. Right from the start, first-year students are taught to think like engineers. One of the mandatory first semester courses is about sustainable design in engineering. And in that class, we learn about the design process, climate change, and sustainability, and project management. This course also has a lecture component to learn all of these useful things, and that's followed by a lab component to apply what we have learned. In the lab, you're paired with a group of 5 students, and you're challenged to address a need in the world. So your goal is to identify a real-world problem, and from there to design and create a new solution. So this was the project that my group had come up with in our AppSci 169 class. We decided to target the climate change and also sustainable packaging. We decided to focus on plastic caused by single-use shampoo and conditioner bottles. The average Canadian uses around 10 of these bottles every year, which really adds up thinking about how many of these end up in the trash and are not recycled properly. Through our research, we found that copper has antimicrobial properties, and we thought that it would be the perfect material to rethink waste and reimagine what a solution could look like. For this project, as you can see, we began with a very rough prototype and then moved on to 3D modeling and finally created a better prototype for our final solution. In the second semester, we are in a drawing and computer-aided design class that follows a similar format. So we have a lecture twice a week, followed by a lab where we are able to work with students. As you can see in the next slide, we have the problem this semester to deal with forest fires. As many of you guys know, forest fires are a very big issue all around the world, but are specifically relevant to British Columbia. This semester has just begun, so we're not very into the project yet, but my group is planning on creating a sensor to detect forest fires early on and notify local authorities. In this class, we learn a lot about computer-aided design and learn how to use SolidWorks, and also about the drawing aspect of engineering. We learned technical courses like computer-aided design, coding, sustainability, and how to do a lot of calculations. But more than that, as a first-year student, we learn about critical thinking. And these have taught me a lot about teamwork and problem solving. We face a lot of challenges through the semester where we have to learn how to navigate challenges related to timing, budget, and the limited knowledge that our students have right now. But we've learned to overcome these challenges, to work together as a team, and to create something that is life-changing and that could potentially change the world someday. These courses are teaching me to think like an engineer, to spot problems in the real world, and to use my skills to solve them. I've really appreciated this opportunity to grow and learn and be able to see a problem and create a solution. And I really appreciate all of my professors at UBCO and all of the faculty who have allowed me to learn so much about this entire process. Thank you.
Mehak, I know you were mentioning before we joined the session today that you were looking at your second year programs and things like that, and that selection is coming up soon for you. Has your experience in your courses given you any insight into what program you're thinking of choosing for next year?
I really appreciate the general first year at UBC Okanagan just because I'm very indecisive about my choices. So I really like having a taste of everything. One thing in specific is that in high school, I was not a big fan of electricity and magnetism units, but I'm currently taking an electricity class, and I find that I actually really enjoy it. And I never considered going into electrical engineering before, but through this class, it's shown me that it's shown a lot of the visual and creative aspects of electricity and magnetism as a subject, and that has made me interested in potentially pursuing electrical. Other than that, I've been able to learn a little bit about civil engineering through my statics class, and overall, those have just allowed me to have a little taste of everything to see what I like about certain programs and what maybe just isn't for me in certain programs. So it's been really helpful to get a taste of everything and see what other options are in engineering. It says, what advice would you give to future first years about making friends and building community in first year engineering? One thing that really helped me with building community and making friends right from the start is that both UBC Okanagan and UBC Vancouver offer orientations. And in these orientations, I was placed with a bunch of other first year engineering students. So we were all sort of in the same boat and we had a lot that we could relate about. And I found that that first orientation was where I found probably 3 or 4 of my closest friends who I sit with every day, who I eat lunch with, and who we study together with. So I would say if you have the opportunity to go to one of these orientation events, like Create or Jumpstart, I would really recommend that. It's really nice having those places where a lot of first year engineering students are all together in the same place, because we're all a little bit shy, a little bit hesitant at first, but then you sort of realize that you have a lot of stuff in common with these people. And there's another question here. Um, do you still finish your degree in 4 years, excluding co-op?
Yeah, this is a great question. Just to be mindful of Mehek's time, we'll answer Vikram your question a little bit later on here. We do have one more specific one here for you, Mehek. A really nice one that came in. So we would like to know, were you already exposed to engineering personally before getting into UBC? If so, how did this affect your understanding of the engineering course when you started? And what advice would you give to someone who is not as exposed to engineering fundamentals prior to university?
That's a really good question. So before entering university, I knew a little bit about engineering just through some of the field trips I'd been on to UBC Okanagan. As a high school and middle school student, I went on field trips targeted towards female students to teach them about engineering. And those had really helped me understand what engineering is all about. Um, but other than that, I didn't really know anyone who was an engineer before this program. And so I would say that if you also feel like you might not know enough about engineering while you're starting, just understand that there are many people in the same boat as you. And the curriculum really teaches things from ground up. And there's many opportunities to learn about the workforce and to learn about industry and other options past engineering once you get to UBC. So I would recommend if you can reach out to people who are in engineering, maybe have a little conversation with them. People are very open to speaking with you, speaking about their experience. If you just reach out, I'm sure that many people would be happy to sit on a Zoom call and have a quick chat. And those conversations are so valuable. I've learned so much just from speaking to advisors, to speaking to my professors. And yeah, I would recommend trying to reach out and find people.
Perfect. Thanks again so much, Mehak. It was great to hear from you. We're going to be sharing a few quick student stories with you so that you can also get to know some of our current students and all of the amazing things that they're working on that you may not have thought as being what a typical engineering student might be working on. So if you are interested in making a more sustainable world, engineering is a degree that can help you do so. While Juliet was studying civil engineering, she learned all about how sustainability can and should be part of engineering work. Juliet identifies as a queer woman and built strong friendships and mentor relationships in the Women in Engineering Club that helped her gain confidence through the support of other women. Juliet was on the third quadrant design team and was the building science team co-lead. Third Quadrant recently won third place at the 2023 US Solar Decathlon Build Challenge against many other top engineering institutions. Now, this project was to make a sustainable living lab, which was created and has actually been built on UBC's Vancouver campus. Now, this was a student-built project built on our campus. So if you ever do come for a visit to campus, you can check it out. The space is still there. It will be developed into a usable student space soon. And you can see a small inset of the space in the picture of Juliet on the screen right now. So it's a really cool opportunity where it's the first building that a student group has built on campus. So it's a really cool opportunity. They did amazing things, and this place is going to be able to be used and remain sustainable for years to come. Another outstanding student that's an international student that I wanted to mention today is Matthew, who actively engaged in extracurricular activities. And during the first year, he was part of UBC's solar design team that builds solar-powered racing cars. In third year, he joined the UBC chapter of Engineers Without Borders and was part of a smoke-free home venture, which designs, builds, and distributes eco-stoves to family in Guatemala. Matthew has interest in sustainability and has always worked to seek out solutions as an engineer. His capstone project with Seabrick is developing sustainable bricks made of kelp for use in construction. And he was also part of a national engineering conference on sustainability that brought in students from across Canada to explore these topics in depth. Now, a UBC engineering degree can truly take you anywhere. UBC Engineering offers a lot of global opportunities through our unique Coordinated International Experience program. And Tina, who went to the University of Hong Kong as an exchange student, combined her knowledge to take lab classes like electrooculography, where you can actually use eye movements to control a computer mouse, I should say. She did 3 different co-ops, and her last co-op was software development for a startup company in the digital healthcare industry, which is where she'll be working after graduation. So some really cool students doing some very cool things that you wouldn't typically think of in engineering. Now we have a few more to share from the Okanagan campus, and I'm going to pass it back to Kyle for just a couple minutes to share those student stories.
Thanks, Aaron. We've been chatting quite a bit throughout this presentation that there really are so many ways to get involved during your engineering degree. Enan, one of our current students at UBC's Okanagan campus, he has direct advice. If there's something you are even slightly interested in, whatever it may be, if it's studying abroad, getting involved in co-op, a club, design team, campus job, taking a particular course, he says, do it. Just do it. Get involved. Get outside your comfort zone, try something new. In Heenan's second year, he worked with a group of fellow students who qualified for the Canadian Stratospheric Balloon Experiment Design Challenge, where they got to launch a testing apparatus to monitor single event upsets with the Canadian Space Agency in September 2022. They collected data that could be used to develop protective techniques to store data on satellites, rovers, and space telescopes. How cool is that? He wasn't involved with anything aerospace before getting involved with that group, and then ended up competing on a national stage. That was pretty darn cool. He then also studied abroad at the Technical Institute of Denmark, where he took courses that included machine learning, data analytics, and the Internet of Things. And this also provided him with the opportunity to travel, go as far as south of Greece and east as Lithuania and Bulgaria, all while taking courses within Denmark. Pretty cool opportunity where you get to see other parts of the world and learn some travel maturity along the way as well. Heenan also participated in our co-op program. He worked with Collins Aerospace and the Seed Corporation. He was able to combine the skills that he gained in his machine learning from his studying abroad with his manufacturing knowledge. Some really cool stuff. We've got lots and lots of student spotlights to share. It's really tough to narrow them down, but we've got another one from one of our international students, Samuel. Many of our engineering students are really passionate about giving back to community and supporting the next generation of engineers. And Samuel took it one step further to give back to the community that he grew up in. Samuel grew up in a refugee camp in Kenya and came to Canada through the World University Service of Canada's Student Refugee Program. And during his degree, he was part of World University Service of Canada at UBC. And he advocated for funding to give other students from refugee camps an opportunity to come to UBC and study. That's amazing. Real world impacts during his degree. Starting in first year, Samuel was involved with the Engineer Student Society, which is a student-run club advocating for current engineering student. In his roles, he helped come up with ideas for on-campus activities, events, initiatives for students, and represented and advocated for civil engineering students during faculty meetings. So getting to sit in with faculty decisions, advocating for current students, pretty intense stuff, and probably an intimidating time going into that meeting for the first time with faculty. Another great story. One of our student athletes, also a fellow international student, is Helen. She is from Brazil. She came to UBC on an athletic scholarship, playing for UBC Okanagan's Heat women's volleyball varsity team. So she's juggling varsity athletics as well as an engineering degree and following passions along the way within her engineering studies. So she's always loved tall buildings, and she's been fascinated by how they're built. Helen has been the president of the student chapter of UBC's Canadian Society for Civil Engineering and was a research study assistant at the UBC Integrated Transportation Research Lab, where she was able to collect data related to whether travel behavior has changed or not since COVID-19 pandemic. But There's so many ways for you to pursue your passions throughout the engineering degree, be it inside the classroom or beyond. And we encourage you to explore all of your options as you're making a decision on a university or on a program within UBC's opportunities. We really want you to explore all of your opportunities as you look to create an experience that's unique for you.
So, in addition to all of the opportunities available to you as a student, engineering truly sets you up for success in your career. Engineering provides a solid education in problem solving, analysis, application of knowledge. So, no matter what you want to do in the future, you have a reliable foundation to continue in engineering or whatever else it is that you're interested in. Lifelong learning is one of the graduate attributes that all engineering students gain. Engineers are improving the world around us, and to do so, they need to keep contributing to their knowledge and applying that knowledge to solve new problems. With a solid foundation, engineering can also open doors to graduate studies and research, law school, medicine, and so much more. Our students, alumni, and professors are continuing to showcase the impact they can make on the world through their research and actions. For example, UBC Engineering is providing solutions of clean water to Indigenous populations in Canada that have been under boil water advisories for entire generations. We have researchers that are removing forever chemicals from water, reducing food insecurity, making an impact on pollution and air quality, preventing and treating concussions, creating new medical devices, and so much more. In your free time, Google UBC Engineering Research to discover just some of the exciting research happening by our faculty, or you can also check our website. We have research in action that highlights some of our current research professors and what they're working on. Now, engineering is also a very well-paying job, and a recent study by Statistics Canada published in 2020 shows that the most top-earning graduates in Canada come from engineering disciplines, and this is when comparing bachelor degrees in Canada. So when adjusted for age, institution, and graduation year, the median earnings for engineering degrees in the top 30 were between $70,000 and $120,000 for both men and women. UBC Engineering is working to also reach gender parity in engineering. And the only way that we do so is through our recruitment and outreach efforts to expose more girls, young women, and underrepresented populations to the field of engineering. One of those could be one of those activities that Mehek said that she was a part of in high school. Some of our other outreach initiatives include Gearing Up. We have our engineering stories team, which I'll talk about towards the end of the presentation, and we have recruitment events as well. Increasing underrepresented populations in engineering make our teams more diverse, and more diverse teams mean that our students are better able to solve problems for the entire population, not just a fraction of it.
Thanks, Aaron. Yeah, so as you're making these decisions, oftentimes students will determine I really want to go for engineering and I'll figure out my career later. Or sometimes they work backwards. I absolutely know I want this job. What do I need for a degree? Oh, it's engineering. Sounds great. Let's do it. Let's take a closer look at where an engineering degree can lead you. You're often asking, what happens after I graduate from engineering? And this is a truly exciting response. You get to choose. There's so many opportunities. Engineering provides you a solid education in problem solving, analysis, application of knowledge, design, technical skills. No matter what you do in the future, you will have a very strong foundation to continue either in engineering or your desired field. Most of our engineering undergraduate students who graduate, they do go on to work in engineering, but it's not limited to engineering. A lot of engineering graduates will go into law school or medical school, or they work in business or start up their own engineering firm. Maybe they get into the government or even go into space. The possibilities are truly endless. But we do have a few highlights to share with you from our recent graduates and some exciting ventures that they're heading off in. I'd like to chat with you about Arpon. He recently graduated from our biomedical engineering program in 2022. And after graduating, he founded a startup company called Clairvent Medical. How cool is that? This is like Hollywood movie type stuff. But it's a spinoff from a nonprofit that he was involved in during his undergraduate degree. His company's now partnering with Vancouver General Hospital and BCIT to get it ready for commercialization and patient use. Companies also developed Bubble Helmet, which uses creative positive pressure environment that helps the patient breathe easier. Aaron, what am I doing with my life compared to what ARPAN has done? This is insane. I'd also like to chat about Bowen, graduated from civil engineering in 2008 and has worked on major construction projects, including at the Vancouver International Airport. She's gone on to become a politician now and currently serves as the MLA for North Vancouver and Lonsdale, and is also the Minister of State for Infrastructure in British Columbia. More real world impacts, making our community a better place. Pretty incredible stuff. We also have Joseph. Joseph had a desire to study engineering and was inspired by wanting to make a positive difference in the community. During Joseph's degree, he was involved in many clubs, including the International Student Club, the African Caribbean Student Club, and also started UBC Okanagan's Global Engineering Community, a group that brought together professors and students for tea to chat. It was a great way to break down barriers, break the ice, and make it easier for students to interact with professors during the year. And I can tell you, still has an impact on the Okanagan campus today from what Joseph started up. After he graduated, he worked in Kelowna for the Watt Consulting Group, and it was a multidisciplinary engineering consulting company. And from there, he was able to move to the Lower Mainland and work in traffic operations and transportation infrastructure for the city of Surrey, and now recently joining the city of Vancouver. So making it a more enjoyable commute for you to get from the Lower Mainland down to campus. Aaron benefits from that directly. But some really cool stuff that's going on. Now I would like to, again, stop talking. You're not here to hear from me. You're here to hear from students. I'd like to introduce you to Emma Gray. Emma's joining us. She graduated from engineering physics at the Vancouver campus in 2022 and now works for Microsoft. Not sure if you've heard of that company before. I think it's a fairly common one that's out there.
Just a little,
Totally
just a little
teasing.
company.
Emma, thanks so much for joining us tonight.
Hi, everybody. My name is Emma Gray. I graduated from UBC's engineering physics program in Vancouver just last May. Gosh, no, 2 Mays ago now, 2022. Time flies when you work full time. And I am a product manager on Microsoft's education team. So a little bit about what that is, if it lets me move to the next slide. There we go. Cool. Starting with actually engineering physics. So this is a very multidisciplinary program. It combines mechanical, electrical, and computer engineering with some software, lots of advanced physics, and more math than probably I ever needed to learn. Students also receive training in all sorts of things. So we took courses in leadership fundamentals and communication, learned about public speaking. We had to give our own TED Talks. We brought in specialists on emotional intelligence and mindfulness. And it's a very versatile degree. So you can choose from electives that span more than 15 different specialization areas, including environmental, astronomy, physics, certain mechatronics specializations, and entrepreneurship. So I ended up falling more into the commerce and entrepreneurship realm of electives in engineering physics. 2 gifts here. One is something invented by a member of the EDART organization, which is an EngPhys founded nonprofit. It's all about bringing engineers and artists together. And on the right is a project by a Vancouver-based engineering physics founded company called Misty West. They invented a haptic hologram. So imagine a 3D hologram in space, and you can touch it with your hands. It was shooting compressed air at your hands at the right time. So it's a very Star Trek and really cool. And they worked with Intel on that. So many, many different disciplines all in one place with EngPhys, and that's a really fun thing about it. Product manager is not a traditional engineering career path, but more and more people with engineering degrees are ending up in this area. And I get to work right in the intersection of technology, business, and user experience design. And that was a really good fit for me, and I'll explain a bit about why. But first, here's your first AppsI 100 slide. This is something that's actually followed me through my entire career so far. And that I first saw in my first term of UBC Engineering. This is the bedrock of engineering design, and they're right, you get to do it straight from first year. The way it applies to my day job today, I'm the one who chooses which problem to solve. I'm the one doing the research. I'm working with research teams to clarify and study those problems. I work with the engineers and the designers very closely to generate solutions to the problems that I choose. We do many rounds of feedback and prototyping. We use the data from our prototypes to identify the most promising solutions. We do countless rounds of testing as well and development. We work with focus groups, and in my case for education, of teachers and students from around the world to make sure what we're inventing actually solves the real world problems we're trying to solve. We iterate many times, and then I get to work with the business people, the marketing folks, PR, developers, designers, to make these solutions accessible on a global scale to hundreds of millions of students and teachers around the world. So very cool kind of process that I get to spend a lot of time around in my day-to-day work. Microsoft Education kind of touches on all sorts of things. Maybe you've heard of Minecraft or Teams for Education. Maybe you use it in school. If you have issues with it, let me know. I will send the complaints to the right people. But we are the voice of the educators and the students to the rest of Microsoft, and that's a really cool spot to be. Now, I'm going to show you a video next of a project that I got to work on that I'm very excited about. My teammates put a fantastic video together, and I'll show that to you here to give you an example of the kind of work that we get to do.
Reading Coach empowers learners to master reading through independent practice that's personalized, engaging, and moderated. It's available to use in the classroom or at home, as a Windows application, or as a browser-based experience. Meet Avery, a bright 8-year-old in the 2nd grade. She's working on her reading fluency, and her teacher suggests that she use Reading Coach to practice reading for 20 minutes a day. Miss Coleman trusts the tool because it applies proven fluency techniques, and it's been endorsed by her fellow educators and reading experts. Let's check it out. As soon as Avery launches Reading Coach, she can create her very own stories. Avery loves dogs and tales about space, and today she gets to combine both in her first ever custom story. She picks the reading level that feels right to her. Reading Coach comes up with a one-of-a-kind story of Avery's choosing, all about Rover the dog. Before she starts reading, Avery can make the text more accessible to suit her specific reading needs. For any tricky words, she can check the built-in picture dictionary and hear the pronunciation with the immersive reader.
Curious.
Now she's ready to read the story out loud.
Rover the dog was always curious about the world beyond his backyard.
Once Avery wraps up the first chapter, she gets kudos for her great work. Like Miss Coleman suggested, she then practices the words that were challenging for her. She's coached on each word as she reads them out loud and continues until she gets all of them just right.
Colorful.
Colorful.
Great reading.
Then she gets to choose what Rover does next. She wants to see Rover go stargazing. Behind the scenes, Reading Coach incorporates the words that she struggled with in the last chapter into the new one for ongoing practice. Before she knows it, Avery's read for 20 minutes. She's unlocked a new character to create stories with, an otter. After one last chapter, Avery's done. She sees how long she took to read, the badges she earned, her accuracy, and the words that were challenging for her. She can't wait to create her next story featuring her hard-earned otter. Avery can always return to any story or passage she's read if she'd like to keep going or read them again.
So that's just one example of something we got to work on. This is something that will increase access to personalized education for students around the world, even those who don't have access to their own tutors. And it's available for free today as of I think 2 or 3 weeks ago now. We just announced it. It's really exciting. So thinking about the possibilities, right, of creating low stakes, easily accessible learning technology for students around the world, it's a really exciting opportunity and a really fun thing to work on. So a little bit about my own background. For a while, I thought I was going to go to art school. That was my favorite thing in high school. And then I quickly pivoted, maybe thought science, medicine, that's where I was going to go next. Landed on engineering for my degree and then fell in love with design. And this is a graphic that really summed it up for me. It's from Professor Neri Oxman at MIT. And for any of you who might be torn between the creative disciplines and some of the more technical ones, this is just here for you to know that this is not something that you need to necessarily pick one or the other for. And so art can lead into science, can inspire engineering, which inspires design. I'd recommend looking this up and watching the video on it. It was a really sort of an epiphany kind of moment for me when it came to realizing that I can encapsulate all of these things into my career and my academic journey. Speaking of the journey, I'm going to run through this very quickly, but happy to answer any questions that folks have. I started at UBC Engineering in fall of 2016 after graduating from Western Canada High School in Calgary. That summer, I volunteered at the Crumble Neuroscience Center for Engineering and Neuroscience Engineering Research. I joined Integrated Engineering, and you saw in the chat that was actually my 4th or 5th pick, but I don't regret being in that program for a year at all. I made incredible friends that are still my friends today. gained a lot of breadth through my time in that program. And then I joined UBC BEST, so the biomedical engineering student team. You saw that briefly earlier. That summer, I did a co-op at the McKeag Institute for Biomechanics. So I was working in a lab, creating new 3D scanning software techniques to figure out how we can help kids with chest wall deformities. And I applied to transfer to engineering physics, and I got in. And so fall 2018, started in EngPhys, became the co-captain of my student team. There are always opportunities to progress in student teams and try out leadership roles, which is awesome. And then that winter and spring, EngPhys students do their first co-op in the springtime. I did it at Misty West, that company that did the haptic hologram. I missed that by a couple of months, which was a bummer, but the work we did was very exciting. I also competed in and won my very first hackathon. That summer was UBC's Engineering Physics' very famous robot summer. Not a lot of sleep, but lots of learning. And I also spent some time on the side building a giant butterfly with that EDART foundation that I mentioned earlier. So this was a mechatronics and art project. You can see how I could bring my passion and my new engineering skills to one project at once. They even sent it down to a number of big arts festivals in the States, and we got to exhibit it in Vancouver too. So a really, really cool experience with my engineering physics friends, and alongside UBC engineering graduates as well on that project. That summer was my very first garage internship with Microsoft, so that's where it all started. They gave me a onesie, and COVID had hit at that point, and so I was doing it entirely from my basement. Still an excellent experience, and I got an offer to come back as an intern the following year as well. Now, fall 2020, I had another co-op because Exchange was canceled at a startup called VodaSafe doing life-saving underwater sonar scanning technology, machine learning. And then fast forward to summer 2021, another fully online Microsoft Education internship where I got my full-time return offer. So I went into my last year of school without having to do a job search. This is a really cool thing about internships. Often they give you a branch to that full-time role, and it's really great. I TA'd two of my favorite commerce courses in back-to-back terms. Another opportunity, again, to just get that breadth in your engineering degree. In this case, it was Innovation Leadership and Design Methods for Business Innovation, two of my favorite courses in my time at school. And then I graduated. Here's me with a bunch of my other EngPhys friends. Our course group that year in our discipline in EngPhys was about 30% female, which was awesome. And then I traveled. I traveled for 4 months before I started at Microsoft Education here in Vancouver. It's the office I'm working in right now. Fast forward winter 2023, you might recognize this guy announcing our big sort of feature launch in the winter. I had an opportunity to work on 2 projects for information literacy, teaching kids how to think more critically as they navigate the internet. And those were announced as a part of that project. So I shipped my first product worldwide, very exciting. And then last week, I was in London, England, presenting this project and others at the world's biggest education technology conference in London. So the travel opportunities, the interdisciplinary teams, all of these things built on the foundation of my engineering physics degree. I think its multidisciplinary nature, the teamwork things that I learned, and just all of the opportunities for breadth and customizing that program for what I wanted to do long-term made a really big difference. And I think that's everything from me. So I will stop with the screen share and I would be happy to take any questions.
So Emma, one question is, can you explain a bit more about what engineering physics is? How might it be different from other engineering degrees? And to talk a little bit about the course load.
Yeah, for sure. So for those of you following the chat, I dropped another link in there that talks about how UBC EngPhys has played a role in Vancouver's tech economy. But the actual program itself is different from other programs in that it's multidisciplinary. So you may have noticed I was in integrated engineering first. That's almost like your engineering double major. You've got a major and a minor, say in mechanical or electrical, or biomedical or materials, or I know Tesla really loves the integrated engineering, electrical major, mechanical minors. That's a thing that I noticed recently. A lot of friends of mine from that program ended up at Tesla. That was a really good way for me to get introduced to the power of a multidisciplinary program. However, at the time, and I know that it's changed since then, integrated engineering didn't have as many opportunities in software. And I fell in love with software a little bit earlier on in my degree, but I wanted to keep it multidisciplinary. And so EngPhys has a number of software courses. They were about to introduce a new machine learning course as part of its core course load. And so that was something that really nudged me in that direction. I was also a total physics nerd in high school and wanted more physics. And so that was a nice thing to do there as well. Course load is reasonably high. There are definitely people who say it's one of the more challenging programs. I think that really depends on what you find interesting. The easiest program for you will be one that aligns with your interests. But engineering physics definitely has like 6 or 7 courses per term typically, and we have especially nerdy students in our program who will take more than that. All the power to them. It isn't uncommon for engineering physics students at UBC to extend their typical 5-year program to a 6-year program. So I took that detour through integrated, ended up in EngPhys in my 3rd year, and ended up graduating with many people I took first year with, just by nature of the way that the program is structured. And so we decided to extend, well, my degree extended because I changed programs. Other folks decided to extend so that they could take 4 or 5 courses per term and get more co-op experience. And that's paid co-op experience, which also helps with the longevity part of your degree there. And yeah, it's amazing the things that people have gone off to do. Many of us are in software. I've got friends at Google, other friends at Microsoft, of course. But there are folks who have started their own companies, people who are, taking the agricultural wine watering automation market by storm at the moment, people who are working with different kinds of online retailers, folks who are interning with F1 teams in Europe right now. Really, the world's your oyster. I think I just didn't want to specialize in the same way necessarily. And being a generalist has really helped me in my career and the role that I'm in right now. So hopefully that helps. There's an article in the chat that's pretty darn good as well that can explain things.
Awesome, amazing. Thank you for that answer. There was another answer that kind of asked about, or another question, sorry, that asked about kind of why you chose engineering physics, but you kind of covered that as well. So I've marked that as answered. There is a question a little bit that you were involved in so many things. So maybe you can kind of speak to this a little bit about how you got involved in things. But the question is, how accessible are both on or off campus volunteering opportunities for students? Are there any specific resources to facilitate student involvement in community service? So I think that's general, whether that is engineering focus or campus wide, but maybe you want to highlight what your experience was with any of those pieces.
Yeah, for sure. So between my experience and the experiences of friends of mine, there were so many volunteer opportunities, either through engineering design teams, which are extracurriculars. So through UBC Best, we volunteered a lot with different kinds of organizations in the medical technology space around BC. We did volunteer work working on accessible design, so 3D printing a new type of remote controller, an Xbox controller for a young kid with muscular dystrophy, so that he could play video games with his friends, even with his limited hand movement. Really interesting volunteer opportunities of that nature. But of course, UBC and the AMS have so many different student clubs that you can join, many of which coordinate volunteer opportunities. And the really cool thing about the AMS is that if you choose to propose your own club, you can there's like an application cycle every year, I think. I've had friends who've had their specific volunteer groups or causes funded by the Alma Mater Society, which is like our sort of alumni group. They run all sorts of things. Aaron can probably explain what that is a little bit better. But if you have a club idea or a volunteering idea and there isn't already a club or a student team for it, it's really easy to get that idea funded and supported by the university because it creates opportunities for other students to get involved as well. So many opportunities. We were drowning in opportunities to volunteer and get involved with our communities and other communities around the world. That was a really special thing about UBC, I think.
Awesome, thank you. And yes, definitely like there's so much happening on campus itself, but at both campuses, you also have access to transit. So part of your student fees is a UPass, which gives you access to the train in Vancouver, as well as the bus and the Okanagan. So you can get around. And if there is something specifically that you wanted to do in a specific community, that you could take transit to get there and be part of that. So it is possible as well, but there's so much happening on campus too that a lot of students, if they're living on campus, they're probably not leaving campus for much just because there's so much always going on campus. All right. Emma, another question for you that maybe you can speak to a little bit. So engineering physics is a unique program because it actually is a joint program that is partially administered by the Faculty of Science and the Faculty of Applied Science or Engineering. So one of the questions is, what are the advantages of, say, engineering physics over a pure physics degree? Now, I know that you didn't take a physics degree, so you can't really speak to that, but maybe if you can answer your experience from engineering physics and what that would look like on more of just the science side.
Yeah, for sure. So think the difference between science and applied science. Engineering physics students might get more opportunities to apply engineering techniques to physics problems. But though you do end up taking many courses overlapping with honors physics students, especially in the later years of the program. So for me, choosing to go engineering, and this actually relates to another question about me being interested in visual arts. My high school guidance counselor told me that engineering is like a combination of art and science. And for me, that really ended up being true. And I think that that's what pushed me to engineering over something like pure physics. However, it's also, as an engineering degree, something that will open the door to physics graduate programs for you down the line. So I just met up with a friend of mine in London when I was there on the conference. He's doing his PhD in applied mathematics. I know there are folks doing their PhDs down in the States at Caltech and a couple of other really cool sounding schools. All sorts of master's degrees and some straight to PhD in physics from an engineering physics program. So it didn't appear to hurt their chances of going full academic graduate school in physics afterwards, but it did also give them the applied science skills and the engineering skills to pursue a career in engineering should they choose to have done that instead. And so it might be a breadth thing, but I think also there's a hands-on element to the engineering program that you might not get in a pure physics program. And that means that you don't get to have as many like sort of lofty abstract conversations about the meaning of the universe, which I know the physics kids get, and it's so cool. And just the way that my physics classmates saw the world was astounding. So I think that it really depends on where you want to bring your skill sets and what you want to pursue afterwards. Engineering physics was right for me because of the commerce electives, ironically. But that was something that shifted my decision there.
Amazing. Thank you. Yeah, and I think you really touched on it really well at the beginning. So whether you're looking at something like a degree in chemical engineering versus chemistry or engineering physics versus physics, it's really thinking about that difference between science is really learning about the world around us, doing all of that research, understanding what is going on in our world. And then engineering is really being able to take all of that research, take that understanding and apply it to solve those problems. So engineers and scientists work very closely together all the time. And it's not necessarily that you have to select one or the other for you to work in your career. But if you want to be a professional engineer, then you do need to pursue an engineering degree. There are still a lot of science courses that you take throughout your engineering program, but you're really learning that hands-on and that application of science in engineering.